Okay, so talking about nothing to really write down for this one. I just wanted to discuss it. So figure A, 1.10a, shows the results of
The distribution of this is roughly symmetric. It's not exact mirror image, but we have a peak at the center and we have longer tails to the left and to the right. For B, it says that these are quiz scores. It's a big class. And we have data that is skewed, roughly skewed to the left. So remember that the mode is in measure of center, it's the most occurring data value. So for part B, the mode would be 90. If something is called it's unimodal, which I think we use this word here in just a moment, it essentially just means one mode. If it's bimodal, it means that there are roughly two peaks. Sometimes they're exact, sometimes they're really close. If our data is, if we have a large data set and they are slightly off, then we could say, if they're close in value but not exact, then we could still say that it's bimodal. So next example is talking about how we're comparing distributions of household sizes in the UK versus South Africa. And the question is, how do the numbers of people living in households in the United Kingdom and South Africa compare? To help answer this question, we used Census at Schools random data selector and chose 50 students from each country. And here is the dot plot of the reported house sizes. We're going to compare the distributions. So comparing them, comparing the shape, the distribution of the household size in the UK sample is roughly symmetric and unimodal. So again, that means one mode, and we can see that in the distribution, while the distribution for South Africa is skewed right, and it's also unimodal. For the center, household sizes for South Africa tended to be larger than for a UK student. The midpoint for South Africa students in that sample was 6. So remember, the midpoint is that middle value. The UK's was 4. It makes sense when you have it stacked like this, that the household sizes for South Africa are slightly larger. The spread, household sizes for South Africa vary more, 3 to 26 people, and for the UK, 2 to 6 people. There doesn't really appear to be any outliers in the UK distribution. The South African distribution has a couple outliers. I guess I forgot to finish this. The South African distribution has what appears to be 2 outliers, one at 15 and one at, I believe it's 26. So make sure you write that down. Yeah, that's 26. We didn't get a list. So yeah, one at 15, one at 26. And the next example, making a stem plot. So you might remember this. We probably did this back in middle school, making it, we called it a stem and leaf plot. And we still use the word leaf, but what you'll see most often is a stem plot. So these data values represent how many pairs of shoes a typical teenager has. And they took the sample from female students for this particular sample here. So the first thing that we want to do is we want to separate each observation into a stem consisting all but the final digit. So our stems are going to be made up of the first digit here. So the 5, the 1, the 2, the 5. If we look at all of our data values, the ranges from looks like the smallest is 13 and the largest is 51, or sorry, 57. So my stems, the first thing that I did was I put my first digits, 1 through 5. Then I went through and started just recording the data value. So the right side is the leaf. So the leaf of each row is to the right of its stem. Okay, so the leaf is the final digit of each observation. So if you have, so for example, when I recorded 50, I put the 0 here. So that represents 50. The next one was 26. So next to the 2 that I've already written, I wrote 6, and that's how I recorded that. Then the next thing you should do is notice that these aren't in order. Right? So we want to order all of them. So you want to order your leaves, and you also want to write a key. Now, this is actually, some of you have already done with the SAT and ACT, but on the SAT in particular, I occasionally see stem and leaf plots, and everybody has a hard time interpreting them because it's been so long since they've seen them. So, so 1 and 3 in this case represents the female student who reported, or a female student who reported having 13 pairs of shoes. We could say that 2 and 3, to this right here, 2 and 3 represents a female student who reported that she had 23 pairs of shoes. We had another student who reported 23 pairs of shoes. So that's how we make a stem and leaf plot. So right here, this is your final key. So this is, typically the first step, and then this is the last step, and you must have a key. Then we have 20 male students. They sampled 20 male students and asked them the same question. So you have a back-to-back stem and leaf plot. So you essentially can make you have your leaves. Oh, sorry, we need to look at this one first on the right. So we have our leaves. And what they did was they actually spread out the data values a little bit more by creating 2 stems per digit. So what they'll do if they're doing that is they'll put half of the digit. So any leaves that are 0 through 4 on the first stem, and then any data values that are 5 through 9 on the second. And what this will typically do is it will help you, especially if you have a lot of data values, is it will help you see the distribution a little bit better. So, so that's the only difference between this first stem plot and the second one. And notice how, even though there are places where we don't have data values, we still want to make sure that we write the stem there, because that's how we know if we have gaps in data. So then here is the back-to-back stem plot. So they combined the 2. They labeled females on the left side, and they did split up the stems, and they put males on the right side. And so one of the things that I want to point out, I guess I forgot to put on here, is that there seems to be an association between females and the number of pairs of shoes that they own. So typically, at least for this sample, the females had more pairs of shoes than the males did. So gender and number of pairs of shoes, there's an association between those two. Right, I think that's it for this video. Yep, we'll do histograms when I come back. And I apologize for all the background noise earlier. My kids are in the background, and so I can't really avoid that. But anyway, have a good day, guys, and I will see you soon.